Hello, this is section 10.1, Rational Exponents. We're starting a new chapter, and the timing for this is pretty cool for us right now. In this chapter, we're going to be talking about exponential growth, and if you've listened to any kind of news lately, you maybe have heard commentators talking about the exponential growth and flattening the curve with this coronavirus that's been going around. So now you'll have a little bit better understanding of what they're talking about as we learn about these exponential functions. So we're going to start by talking about rational exponents. This is kind of a fluid process. Some of you are really going to like it. Some of you are not going to like it. But I want to encourage you to hang in there and just keep trying. We're going to be looking at exponents that have a fraction form. So we've got the definition of base b raised to the p over q power. We're going to be talking about what does it mean for a number to have a rational exponent, an exponent that's in fraction form. What does that mean mathematically? How do we use it? Why is it helpful? And then also, how are the different ways that we can manipulate it and change it to do what we need to do to solve a problem? That's the part that may get a little bit frustrating, because with some of these, there's not one right way to do the problem. Some of us love having lots of options for solving a problem, and some of us get a little frustrated if we don't just follow the same steps every time to get an answer. So hang in there. We're going to do lots of examples together. And the more you practice these, the more comfortable you will feel with them. So please do the practice. All right, so the definition of a number b raised to the p over q power. If p and q are integers, with q greater than 0, and b is a positive real number, so the base b is a positive real number, then, by definition, base b raised to the p over q power equals, I bet you weren't expecting that, it's got a radical in it. It's actually the q root of b raised to the p power. Or you could say it's the q root of b raised to the p power. It doesn't really matter if you have the p outside the parentheses or the p inside the parentheses. A rational exponent is actually another way of expressing a radical expression. So I'm going to explain how this works. It looks a little weird the first time you see it, but I want you to remember here is that these are like trees. Think of a tree. Where are the roots of a tree? The roots of a tree are at the bottom of the tree. So when you're doing a rational exponent, the root is at the bottom. So when you're rewriting something, so for example, if we had 9 to the 1/2 power, and we were going to rewrite that as a radical expression, 9 is the base. The base goes inside the radical. The bottom number from the fraction is your root, because just like a tree, the root is on the bottom. So the root is here. The top number is your exponent. So this would be to the first power. So 9 to the 1/2 power is just another way expressing the square root of 9. You'll get really used to the 1/2 powers. You'll start to recognize those right away. Whenever you see anything raised to the 1/2 power, I want you to think that's just a square root. 1/2 power is just a square root. So if we were to continue and evaluate this, The square root of 9 would be 3, and 3 to the first power would just be 3. So the answer for 9 to the 1/2 is 3. So we're going to look at doing some of these that are, this was a pretty basic example. We're going to look at making these a little more complex. So for the first one, we're going to evaluate if we have 81 raised to the 3/2 power. So the way we're going to do this is we're going to rewrite it in radical form. So when we go to rewrite it in radical form, you can start with your radical sign. Your base is the 81. The base goes inside the radical sign. Your root is on the bottom. So just like a tree, the root is 2, so that's a square root. And then the top number is your exponent, so that's cubed. Then you're going to do your order of operations. So we've got the square root of 81, which we know is 9. So that becomes 9 cubed, and then if we calculate 9 cubed, we get 729. All right, let's try another one. If we have 8 to the negative 5/3. Now, this is going to require that you recall some previous knowledge from another chapter when we talked about negative exponents. So hopefully you remember that when you have a negative exponent, the way you make it a positive exponent is you move it to the other part of the fraction. So if we start with 8 to the negative 5/3 power, it becomes 1 over 8 to the 5/3 power. When we move that down to the bottom of the fraction, it becomes a positive exponent. Now we can rewrite it in radical form. So for this one, we're going to make 1 over, and then we're going to use our radical sign. 8 is still our base, so it goes inside the radical. Just like a tree, the root is on the bottom, so this is a cube root. And then the top number is your exponent, so we're going to raise that to the 5th power. That's my dog Scarlett, she's saying hi. All right, so on the bottom here, we've got the cube root of 8, which is 2. And then 2 is being raised to the 5th power, so 2 to the 5th power. You'll get really familiar with that one. They like to use it a lot. That's going to be 32. So 8 to the negative 5/3 power, the answer is 1 over 32. Let's try one more before we move on. If we have 9 to the 1.5 power. Now, that is a decimal exponent, not a fraction exponent, but we remember that we can rewrite decimals as fractions, so we know that 1.5 is actually 1.5, and then we do 1 times 2 is 2 plus 1, so that's actually 3/2. So this becomes 9 to the 3/2 power, and then we're going to write our radical sign. Our base is 9, so that goes inside the radical. Our root is on the bottom, so this is a square root. The exponent is on the top, so we're going to cube that. The square root of 9 is 3, and then 3 cubed is 27. That's another one that we're going to use pretty frequently, so you'll get familiar with that one too. So it's pretty easy to move from rational exponents into radical form. And sometimes our brains are a little more accustomed to the radical form, so this makes more sense to us because this is what we're used to. But the more you practice using the rational exponents, the more familiar you're going to become with what they mean. So you're going to read this and you're going to start thinking to yourself, oh, that's just the square root of 81 cubed. You're going to be able to think like that the more you get comfortable with this format. So you can also go from radical form into exponential form. So that's what we're going to look at next. For our next example, we're going to write in exponential form. So they're going to give it to us in radical form. We're going to rewrite it in exponential form, following that same guideline. So if, we'll just do it. If we have the 4th root of x cubed y to the negative 4th. We're going to rewrite this in exponential form. So each piece is going to get rewritten with its own rational exponent. So for the x, when we go to write it in rational form, the root is 4. So when we write that fractional exponent, the root goes on the bottom, the exponent goes on top. So this becomes x to the 3/4. For the y, the root goes on the bottom, the exponent goes on top. So this is going to be to the -4/4. All right, x to the 3/4, that doesn't simplify, but y to the -4/4, that simplifies to y to the -1 power. So you could leave it in this form, or if you're following a textbook like ours where they don't want you to have any negative exponents in a final answer, we're going to resolve that by making it a positive exponent and moving it to the bottom of the fraction. So our final answer would be x to the 3/4 over y. All right, let's try another one. If we have the square root of ab cubed, so we're going to rewrite each part. On this one, a does not show that it has an exponent. So if an exponent's not showing, it's understood to be to the 1st power. Also, the radical doesn't show a root. If the radical is not showing a root, it's understood to be a square root. So for the a value, we have to the 1st power on the inside, square root on the outside, the root goes on the bottom, so that's a to the 1/2. For the b value, the exponent is 3 and the root is 2, so b to the 3/2. So we rewrote it from radical form into exponential form. Let's do one more. If we have 1 over the cube root of xy to the 5th, and we're going to rewrite that. So on the bottom, we have x does not have an exponent showing. It's understood to be to the 1st. The root is 3. The root goes on the bottom. So this is going to be x to the 1/3. And then for the y's, y to the 5/3. So you could leave that as your final answer. Or if you didn't want to have it as a fraction, you could give these both negative exponents. You could bring them up to the top. So you would have x to the -1/3, y to the -5/3. All right, now that we've gotten some practice in moving between the two forms from radical form to exponential form and from exponential form to radical form, let's look at how you would simplify these, because sometimes after you do the moving around, you can actually simplify them. So if we do our first one here, if we have the quantity of 1 over the cube root of 81 raised to the -3/4 power. All right, if you try doing the cube root of 81 on your calculator, it's going to give you a decimal. It's not a perfect cube, so we can't just take the cube root of 81. So we're going to work on rearranging this a little bit. So I'm going to start by rewriting this radical form into a rational exponent. So then I've got 2 rational exponents, and I can work on putting them together. So the cube root of 81, I'm going to rewrite that as 81 to the 1/3. And then on the outside, it's still being raised to the -3/4 power. All right, then I want to be able to work with these together. So I'm going to bring the 81 up to the top. If I'm going to bring it up to the top, I have to make it a negative exponent. So this is going to be 81 to the -1/3, now raised to the -3/4. And then we have to remember our exponent rules. Our exponent rules tell us that when we're raising a power to a power, we multiply exponents. So if I multiply those exponents, a negative times a negative is going to be positive. If I multiply across the numerators, I'm going to have +3. Across the denominators, I'm going to have 12. So we know that 3/12 reduces into 1/4. And now I have the 4th root of 81. If we make our little factor tree, we know that's going to be 9 times 9. And then each of these is a perfect square. So the 4th root of 81 is going to be 3. So The original problem is 1 over the cube root of 81, all raised to the negative 3/4 power. We do some manipulating. We use these rules to transform from radical form to rational form. Then we just follow our exponent rules, and we find out that the answer is 3. All right, let's do another one of these. Like I said, the more of these that you practice, the more confident you'll feel with how to do these. And the more you do them, the faster you'll get. So with each one, if you get stuck, what I want you to do is just look at it and say, okay, I have no idea what to do with this. Is there a way I could rewrite it in a different form? Maybe if you rewrite it in a different form, you'll see something that you can try next. So just try the next thing. If you're not sure what to do with it in this format, rewrite it in a different format. All right, so for this one, we're going to use our rule about radicals. When we have a fraction inside the radical, we can rewrite that as 2 separate radicals. So the square root of 1/3 becomes the square root of 1 over the square root of 3. The square root of 1 is a perfect square, so now this is just 1 over the square root of 3 times the cube root of 9. Then we want to get these in the same format. So I'm going to do a couple things here. First of all, I'm going to rewrite this one with a rational exponent. So I'm going to rewrite this as 3 to the 1/2 power. This one is a base 3 and this one is a base 9. It would be really helpful if I could have them both rewritten in the same base. So I can rewrite 9 as 3 squared. So that's what I'm going to do here. I'm going to rewrite 9 as 3 squared. Now I'm getting closer to having them in the same form. I'm going to bring this one up to the top. So I'm going to make this one have a negative exponent. And then I'm going to change this one from radical form to rational form. The base is on the bottom, the base, and then the root is on the bottom. So we've got 2/3. Aha. Now, we have base 3, base 3. Let's go back in time. Remember when we did problems like this? X squared times x cubed. What's the rule? We would add the exponents and we would get x to the 5th. We're using that same rule here. We have the same base. We have a base of 3. So we're going to keep the base. We're going to add the exponents. So negative 1/2 plus 2/3. You're going to have to get a common denominator and add. You're going to get 3 to the 1/6 power. That's our answer in rational form. Or if they want the answer in radical form, we can rewrite this as the 6th root of 3. Either form is correct. It just depends on if they specify what format they want it in when they're asking for the answer. So we took 2 separate things. We manipulated each one as much as we could. We changed this all the way into rational form. We rewrote this base so that they could have the same base. And then once they had the same base, we were able to combine them together. So we went from 2 separate things that we were able to combine into one answer. All right, there's one more thing I want to show you how to do today. We're going to look at how you can solve equations using these exponent rules. So this is the last concept for this video. We're going to solve. So if we have 6 times x to the 2/3 power equals 54. One thing to note, the 2/3 is only on the x. The 6 is not being raised to the 2/3 power. If they wanted us to raise the 6 to the 2/3 power also, then we would have had to have parentheses here. So it's only the x that's being affected by this exponent. So we're trying to solve for x. We're going to follow our rules for solving an equation. We're going to try to get the x by itself. Right now we have 6 times x. So the inverse operation is to divide. So I'm going to divide both sides by 6. So I have x to the 2/3 equals 9. Now, I want to get the x by itself. I need to eliminate that exponent. So what I'm going to do here is you're going to raise both sides to the reciprocal power. Raise both sides to the reciprocal power. So I'm going to raise x to the 2/3 to the 3/2 power. Well, because it's an equation, whatever I do on one side, I'm going to do on the other side. So I'm going to have 9 to the 3/2 power. Now, let's look at why we're doing this. If we have a power to a power, the rule of exponents says that we multiply powers. Well, if I multiply 2/3 times 3/2, I get 6/6, which is just 1. These exponents end up canceling each other out, which gives me x to the first power, which is what I was going for. I wanted the x by itself. So using that reciprocal power cancels out that rational exponent so that I have the x by itself. But now I have to do this operation on this side. So remember what we learned earlier in today's lesson. We're going to rewrite this in radical form. The root goes on the bottom. So I'm going to make my radical. The base 9 goes inside. The root is 2. And then we're going to cube this. So the square root of 9 is 3. And 3 cubed is 27. All right, last one. We're going to solve one more. If we have the quantity t minus 4 raised to the 2/5 power minus 3 equals 1. All right, take a minute to take that in. We've got the quantity t minus 4 raised to the 2/5 power minus 3 equals 1. Our goal, ultimately, is to get the t by itself. But right now we have something inside the parentheses, we have an exponent outside the parentheses, and we have something being subtracted on the outside. So following the rules for solving an equation, we're going to add 3 to both sides. So we have t minus 4 to the 2/5 equals 4. Now we're going to use this raise both sides to the reciprocal power. So we've got t minus 4 to the 2/5. That's going to be raised to the 5/2 because remember that reciprocal power is going to cancel out. But if I raise the left side of the equation to the 5/2, I also have to raise the right side of the equation to the 5/2. All right, then we've got 2/5 times 5/2 cancels out. So here I have t minus 4. And then over here I have 4 to the 5/2 power. So I'm going to make my radical. The base is 4. The root is 2. The exponent is 5. So t minus 4 equals the square root of 4, which is 2, to the 5th. So t minus 4 equals 32. Add 4 to both sides, and t equals 36. So that's a couple of examples of how you would solve. Later this week, we're going to look at some more examples of how you continue to work with solving these equations. But for today and tomorrow, you're going to just be practicing working with these exponent rules. And I would even suggest maybe doing a few extra problems beyond what was assigned because each problem has its own little tricks to it. The more of them you practice, the better you will get. So hopefully you're enjoying these exponent rules. They can be really fun once you get the hang of them. Just remember, if you get stuck, look at the problem and think to yourself, is there a way I can rewrite something here? Can I rewrite something that's in radical form into rational form? Or vice versa? Can I change the format somehow to help me get to the next step?